today is, what is today, 4th, 5th?
Today's the 5th. Yeah, it's right there.
So today is the 5th. Go ahead and start copying this down. These are today's notes. The word you guys couldn't remember a little while ago.
Equality.
Inequalities.
Inequality.
All right. What are the other inequalities? And you might want to write this down here somewhere. What are the other inequalities?
Wait, the I word that meant like the no zero
Yep.
stuff?
So one of the inequalities is not equal to. What are the other inequalities?
Not greater than equal to.
Greater than equal to.
Less than equal to.
Less than equal to.
Oh, greater than equal than.
Greater than, or I'm sorry, less
Less
than,
than.
greater than.
Greater
Those are all the inequalities. So that's what we're going to be dealing with today.
My brain is not. You want us to do like before after?
Nah, you don't have to. All right, write this down. Shorten this up. I think I stole this from Mr. Harrison. So put in some, like for triangle right here. What could you put in?
A triangle.
Put the triangle. For opposite, maybe shorten it up. You know, make it make sense to yourself, but
Do we have to do a review for this one?
no. We're going to draw a picture with each one of these. If you're writing down the theorems for chapter 5, you might have already seen some of these, so hopefully some of them will click in your head. Notice too, the converse also works. So this theorem says if one side of a triangle is longer than another side, then the angle opposite the longer side is bigger than the angle opposite the shorter side. The converse of that would be to say the angles. If you know one angle of a triangle is bigger than another angle in the triangle, then the side opposite that has to be bigger than the side opposite the smaller angle.
Would be the hypotenuse.
Not the height, because what don't we know about it? Don't know if it's a right triangle or not, right? So the longer side could be whatever. This works for all triangles, not just right triangles. I guess.
Goodness, I felt like
I don't know. Last time, didn't you give me a big headache last time? Didn't you give me a big headache though, along with yours?
Never did.
So don't lie. Tell the truth. Did you give me a headache last time? All right. So what this theorem means, and you got to watch when I draw this because you got to be able to do all this stuff. In this triangle, what do I know about angle A? What do you know about the side across from angle A?
It's 12.
It's 12. How does that compare to the other sides? It's the longest. Which side's the shortest side in this
6.
triangle? And this is what you want to do. Now we're not going to know, and this is going to confuse a lot of you guys because you want exact answers all the time, right? And that's not what we're going to have here. This one's the middle. Well then, what do I know about angle A right there?
It's not a very big angle.
If it's across from the longest side, then it has to be the
Opposite.
biggest. It's got to be the biggest angle.
Are you serious?
Which one has to be the smallest angle in this picture?
Angle C.
Angle C, because it's across from the 6. So this is the smallest angle.
In the middle is B.
And then this one is the
Near that.
middle angle. Now, if we wanted to write that, watch carefully on this. One way I could write it, angle A is greater than,
Angle C.
that's true,
Angle B.
angle B, which is greater than
Angle C.
angle C. Notice how I over-exaggerated those, because what do I not want to get them confused with?
Angle sign.
Angle signs. Tell me another way I could write this, but in a different order. Let's start with angle C.
C is less than angle B, which is less than angle A.
I feel like that one would be more confusing way than going like big and small.
All right, now,
Yeah, or-
sometimes they're gonna ask you to write it big to small, and sometimes small to big, and you gotta make sure you can do it both ways. Does that make sense to everybody, what I just did there?
Yeah, the switch.
Biggest, middle, smallest, using the alligator mouse, the inequality symbols. Here I'm going smallest, middle, biggest. Now, could I do the same thing with the sides? Yeah, if I told you you had this triangle and this angle right here was 90, this angle over here was 40, and this angle was 50. Which side in that triangle has to be the longest side?
BC.
Segment BC has to be the longest. Which one has to be the shortest side?
90 and
AB, over here, that has to be the shortest, and that one would be the middle. Now, do we know exactly what each one is? No, but we know that one's longer than the other, and that's what this theorem's saying.
I was right in that. I'm usually not, but.
All right, write down this theorem. This is probably the one that we use the most.
Wait, what was the last theorem called? Within half title?
I don't think so.
Inequality, inequality.
Hurry up, right, because we ain't got much time.
Sorry, I can't see.
All right, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Probably want to draw this picture somewhere. Trying to think of some numbers here. Lots of different things that we can do with this theorem. One of them is we can find the range for a side. We can't find the exact number for a side, but we can find the range that that missing side has to fall between. All right? If I take my 2 yardsticks here, and I told you earlier this year that triangles are rigid shapes. Let's not even take 2. Let's do this. Make a little more sense. One of my sides of my triangle is going to be this length. One of them is going to be this length.
Can I hold up the other yardstick to connect it?
Can I just form any triangle in the world when I have a side this length and a side this length?
No.
No. Now watch. Am I ever going to be able to make a triangle if I hold it like that?
No.
No. That would work, right? Could I connect that and make some little bitty triangle there? Now, at some point, I can make all those triangles, but when I get here, is there some certain length that that side right there has to be? I could keep going, keep going, keep going. The side, this third side that's missing just keeps getting longer and longer and longer, right? Finally, when I get to about here, am I going to form a triangle anymore? All right, and that's what this is saying. There's some range. That third side could be as short as from here to right there. If I'm as small as I can get, it could be as long as from there to way over here somewhere if I get it out as far as I can. All right, but there's some range there. Can that side ever just be any number? No, it's got to be something special, and it's got to fall in this range. And the way you find that range Watch, this is what I'm gonna write this down so you understand this. The third side always has to be between some number here and some number there. And the way you find this first number, any idea how you might find this side over here?
Take the base minus this one,
What do you do with them?
subtract.
Subtract, good.
Way to go.
So you might want to write that down. On this one, what is 10 minus 6?
4.
So on this triangle, the smallest this side could be is 4.
And then add them together.
And on the other side, guess what you do? You add. What do you get?
16.
Now, be careful, because can the side ever actually be 4? No, because it's got to be greater than 4. So could it be 4.1?
Yeah.
Yeah. Could it ever be 17?
No.
Could it be
15.9.
15.99999? Would that work?
Yeah.
Yeah. So it's got to be in between those two. So that's how you find a range. The other thing they're going to ask you to do is they're going to give you 3 numbers. Give me 3 numbers.
5.
27.
11.
And they're going to ask you, if I have those 3 lengths, can they form a triangle? So we have, let's say this is 5, this is 27, and I have this right here is 11. Let's switch it. This is 5, this is 11.
Use one marker for
Can they form a triangle?
No.
It's not going to work, is it?
No.
Now, the way you can tell whether it's going to work or not is sort of like that part right there, but you got to do 3 separate things. The first thing you do is say 5 plus 27, and our theorem says that has to be greater than what? What's 5? What's the
5 plus 11? 11?
just 11? And then the other one, all we're doing is taking these, putting them together 2 at a time, adding them, and setting it bigger than the third side. 5 plus 11 is greater than, what's the third side? 27. And then 27 plus 11 is greater than 5. You got to check all 3 of those. If it works for all 3 of those, then it could form a triangle. If it doesn't, then it can't. Is 5 plus 27 greater than 11? Is 5 plus 11 greater than 27? So what do we know about these? Is there any triangle in this world that ever have sides length 5, 27, and 11?
Negative.
No, doesn't work. Give me 3 other numbers. Let's try 3 other.
12.
12,
No, because that's
9, 22, 14.
9, 22, 14. Will that work? Can the triangle have sides 9, 22, and 14? Let's try it and see. What's 9 plus 22? 9 plus 22. Is that greater than 14?
Yeah.
Yeah. What's 9 plus 14?
Like 20.
23.
Is that greater than 22?
Yeah.
What's the last one I got to check? 22 plus 14, is that greater than 9? So is there some triangle that can have sides that length? Yeah. And that's all you're doing is checking to see if that works. Either finding the range for that third side or checking to see if it's possible for 3 numbers to be the sides of a triangle. All right, write this one down. This one, we're going to hurry through this one because I don't particularly care for it. What do you know about angle 1 and angle 2 here? They have to what?
Add up to 4.
Add up to 4. Remote interior angles, right? Well, what this theorem says is that angle 1 has to be less than angle 4, and angle 2 has to be less than angle 4. Well, no kidding. If 2 angles add up to be more, or if 2 angles add up to be an angle, then either one of them separately has got to be smaller than that other one, right? So this is sort of a common sense theorem. So if I had something like this, I think this is one of the problems off of that packet. It gave you something like this, told you that this angle was 50. And then it wanted to know what you knew about this angle out here.
It was
Well, you know that it's, if nothing else, it's got to be greater than 50. It's got to be more than 50. All right, distance, don't write this down because we've done this like 5 times this year. If I give you this segment and you're standing at a point out here, how do you find the distance from that point to that segment? What do you gotta make sure you do?
This is one
Go,
Straight down.
it's gotta be what to the segment?
Perpendicular.
Perpendicular. Make sure you remember that, we use that again this chapter. All right, this is your assignment on 2 separate pages. Page 252, page 264. Also, don't forget the E-Day, the packet, the triangle, and there's something else. Oh, the quiz on Moodle. If you weren't in here when I went over that, a couple of you had left. Please make sure you talk to your peers. The quiz on Moodle. You get on Moodle, there's a quiz under today's date. You click on it and you can take the quiz. It deals with medians, altitudes, all that different stuff.
And you watch the videos at the bottom before it.
If you watch the videos, those would probably be real helpful.
When you said 2 separate pages, does that mean you want us to do it on?
No, you don't have to do it on 2 separate pages. It's just on 2 different pages. So this quiz, E-Day, this is all stuff that's due next week. Worksheet, remember the worksheet will be bonus. The triangle would be bonus.
Okay, so when you say the triangle, we can't just like say it is this.
No, it has to be.
Okay. I don't know. So, what if someone brought in like a lot of papers like all taped together?
Well, like,
Sarah, we're doing that tonight.
okay, we're fine as a group. I have 2 people.
I'm just gonna go up to my mom and be like,
Hey, if you do it in meters, if you do it in meters, so it can be a group. Sarah, we are so doing meters. Yes.
Will we get extra credit?
Yeah, it's triple it. He said, how? You said it was worth the test.
Well,
You
it's
said-
already extra credit if you draw it.
Do you say it was worth the test score? Like 100 points? It would be 300 points, Sarah.
This is supposed to be my smart class this year.
So would it be 300? Like 300 for her, 300 for me?
Let's do it.
We're still
smart.
Yeah. I mean,
A tester ever solved the test.
wait, is a meter 36
Oh,
or
yeah.
39?
Your vocab test and a quiz are laying right here. You can search through that pile and get them.
Yeah, let's let everyone see my score. I got a 90.
Yours is right there.
I got a Wallace, Ariel. Is it Katie?
The other thing, Katie, that right there is yours.
Oh, cool. 95, not bad.
The other thing, I'm passing out interim reports. I did this like the first 9 weeks, and the second 9 weeks I forgot to do it. This is my interim report. This is for this class.
Wait, oh, yeah, I thought you were handing out like one class one. I was like,
I got a smiley face.
dang, what time did I miss?
Oh.
Oh, I only missed one.
Is everyone getting these, or is it
So-
really missing
But
something?
this is just for my class. Most other teachers don't do this.
Mr.
This is
Eversole.
telling you what you're doing in here right now, and it explains why. You could get online and see it. Same anywhere else.
Just so you know, when me and Sarah bring in our meters triangle,
I'm gonna have a big long laugh.
I thought we're gonna have like a 100%.
I'm doing miles.
Hey, I'm doing miles. Just so you know. Hey, Mr. Eversole. Just so you know, when me and Sarah bring it in, we each get 300 points. So we're gonna have like 150%. Yeah.
Isn't she weird? She's only like crack at you.
because I forgot to give it to you. I like just remembered when
since-
you said something about the
No, we're
homework and
doing the
forgetting
mild
it.
one, okay?
Look, so that you guys aren't as silly as everybody else is gonna be. Let's go back. Oh shoot, I forgot to turn off my